Hello, my dear students of grade 10. Welcome to today's lesson. Today, I am going to discuss with you all changes in matter. This is the 16th lesson of your grade 10 science textbook. And as you can see, it is a chemistry lesson. So, you're familiar with matter. What is matter? Anything that occupies space and has a mass is known as matter. And you are familiar with the three different states of matter: solids, liquids and gases. So in our day-to-day life, we come across lot of things. That is, there are different types of matter that we use in our day-to-day life. And you all have observed these matter undergoing changes. For example, if we have something made up of iron, you have seen it undergoing rusting. Then you can see fruits, ripening of fruits. At the same time, you see different substances changing from one state to the other. For example, you have seen ice becoming water, water becoming vapor, again vapor condensing and forming water, water becoming ice on cooling. So like this, you have seen lot of changes taking place. Now matter undergoes changes that can be either considered as physical changes or chemical changes. So basically there are two main types of changes that matter undergoes. Out of those, we will be concentrating on chemical changes mainly. So although we discuss the changes in matter, we try to understand the physical changes, chemical changes, and thereafter we will be concentrating on chemical changes mainly. So that is the introduction to this lesson. With that, I'll move on to the next slide where we look at the contents of the lesson. Changes in matter. So under that, we will be looking at chemical changes. As I told you all, there are two main types: physical changes and chemical changes. We will focus on chemical changes. Again, you are familiar with these, students. Now, physical properties. When you have a solid, the physical properties. Liquid, gases, the different physical properties. For example, density, ability to conduct electricity, melting point, boiling point, those are usually the physical properties. When we say chemical properties, the way different substances react with other substances. So there we consider the chemical properties. You all have discussed the physical and chemical properties of metals, non-metals and metalloids. So you're familiar with these types of properties. So here we will be looking at chemical changes. Then we have chemical equations. So when substances undergo chemical changes, to denote those changes or show them, represent them, we use chemical equations. Again, you are familiar with chemical formulae. The formulae that is used to represent any elements, the symbols of elements as well as compounds. So using those, we will be representing the chemical changes, that is the chemical equation. Then we will look at the reactivity of metals. Again, you are familiar with this concept. Now, when you take jewelry made up of gold, we use gold or even platinum, sometimes silver. These do not tarnish very quickly. Whereas you have seen magnesium strips in the lab, they tarnish very quickly. So there you can understand the reactivity of metals is different. So that is what we will be discussing under reactivity of metals. And based on all these reactions, how metals react with other substances, we will discuss the activity series. And finally, we will be discussing gases. There are different gases that are useful to us. So like oxygen, carbon dioxide, hydrogen, these are different types of gases that we use for different purposes in our day-to-day life. So we'll be looking at gases, their preparation, how they can be prepared in the laboratory, their properties, both physical and chemical properties, and their uses. So gases, their preparation, properties and uses. Those are the contents of this lesson. With that, students, I will move on to the next slide. Look at these pictures. The first one, can you see this diagram? It is a metal cup. Actually, we can say a cup made up of iron or even steel. So, usually if you have a cup, any object that is made up of iron, if you have it, if you use it for a very long period of time, you can see the rusting of that object. So, here also, if you look at these parts where it's white, still the cup is the same way. But at these parts, especially this part of the cup, and here you can see the difference. Difference in property, difference in appearance, and you all know that is rust. The reddish brown or dark brown substance here, that is rust. So, iron undergoes rusting. Objects made up of iron undergo rusting. So, that is a change. The metal cup, that is the iron cup, is a matter, and this matter undergoes changes. So, this is one type of change. Then you have seen these also. We call it the mothballs or the naphthalene balls. We use them to repel some of the insects. So, you have used this at home or you have at least seen them at home. What happens there? Now, if you take these mothballs or the naphthalene balls, if we put it into a cupboard or even a container, and if we have it for a few weeks or sometimes a few months, you will see the size of these mothballs decrease. Sometimes, if the weather is very, very hot, you might have even noticed a liquid-like substance there. And also, you would have felt the smell of naphthalene balls in air. So, there what happens? The size of the naphthalene ball decreases. So, after sometimes the naphthalene ball itself will not be there. So, completely it can undergo a change. It can become vapor. It sometimes turns into a liquid and then vaporizes, or directly from the solid naphthalene we get the naphthalene vapor. Solid becomes a gas. So, that is another change that occurs in our day-to-day life. You would have seen it. Another common example, ice cubes. So, you can see the ice cubes there. If you take a few ice cubes, keep it on a saucer, if you just keep it outside on the table, what happens? Obviously, you all know the ice melts and it becomes water. The same way, if we heat water, it becomes water vapor, the steam. So, like that, there is a change from one state to the other. Now, out of these three, if we consider the three examples, these two, you all can see there is a state involved. Now, from the solid state, you get the liquid state. So, there is a change in the physical state of these matter. But here, you can see the iron rusting. So, there of course, different substances are formed. So, you can understand this change is different from the other two changes. So, that is where we will be discussing chemical changes and physical changes. So, if you are to write down the changes that take place here, rusting of iron. Rusting of iron. Then if we take the mothballs or naphthalene balls, vapor is formed from solid. Then we have the ice. Ice melts to give water. So, three different changes. As I told you all, the first one, rusting of iron, is somewhat different from the mothballs going from solid state to vapor state, that is the gaseous state, and ice solid going to water, that is liquid. So, there we will be discussing both chemical and physical changes. With that, I will move on to the next slide. So to understand these changes, we will do an activity, observe changes in matter. So for that, I have these required materials. You all can see here, students, the first two materials. What is this? You are familiar with that. Magnesium strip that is available in the lab. So this is magnesium strip. Magnesium strip. Then we have sulfuric acid. Sulfuric acid. And that also the dilute sulfuric acid. So normally you all know, students, in the lab we have different acids that are most commonly used. Out of that we will be using the dilute sulfuric acid. Then here I have sodium hydroxide. Sodium hydroxide pellets. Sodium hydroxide pellets. You all know the meaning of pellets, like small tablets, like chips, you get the sodium hydroxide solid. So that is why we call it as sodium hydroxide pellets. Then we need metal spoons. We will be needing 2 spoons actually, the normal metal spoons. Then we have the other material. You can see here, this is familiar to you, naphthalene balls. Naphthalene balls, or what we call as mothballs. Naphthalene balls or mothballs. Then we need the matchbox. Matchbox with matchsticks in it. We will be needing beakers. Then we need the Bunsen burner. And also we need the thermometer. Thermometer. So these are the different materials that we need. Magnesium, dilute sulfuric acid, sodium hydroxide, we need metal spoons, then we need naphthalene balls, we need matchbox, beakers, Bunsen burners, and or just one Bunsen burner is enough. Then we need thermometer. So those are the materials that we need for this activity. And in this activity, we will be looking at 4 different changes. So I will move on to the next slide where we look at the procedure of this activity. Method. Do the activities given below and record the observations. So as I told you all, students, we will be doing 4 different activities within one activity. That is, we are trying to understand 4 different changes. I introduced you all to the physical and chemical changes. So we will be looking at 4 different changes, and then we will try to understand what physical changes are and what chemical changes are. So the first one, heat a metal spoon strongly in the Bunsen flame and take it away from the flame. So you heat a metal spoon and when it becomes really hot, you take it away. After we heat the metal spoon, we take it away from the flame, and thereafter what do? We need to place a mothball on it and you need to observe it. So you all know mothball is a solid, a white color solid. So you put 1 or 2 mothballs onto the hot spoon and you need to observe. And after you observe it immediately, you can see the change. And once the change takes place, what we do is we close it with another spoon quickly. So you have to have 2 clean spoons and you close the first one containing the mothballs with the second spoon. After some time, observe the inner side of the spoon. So after you do this, you have to observe the inner side of the spoon. Then you will see the change taking place. That is the first activity. Then the second one, hold a piece of cleaned magnesium ribbon with a pair of tongues and burn it. So why do they say cleaned magnesium ribbon? Normally, you all know, students, in the lab, when we have the strip of magnesium or the magnesium ribbon, it gets tarnished quickly. And you are familiar with this. There is a layer of magnesium oxide over magnesium strip. Sometimes there is magnesium nitride also. So what we need to do is we need to clean that using a sandpaper. So once you clean it, you will get the shiny magnesium strip. That is the magnesium metal. So that is why they say cleaned magnesium ribbon with a pair of tongs and burn it. So you have to hold it to the Bunsen burner and we need to burn it. So here we need to hold it to a Bunsen burner, the flame of the Bunsen burner directly. So that is the first activity. So you look at the strip of magnesium and when you burn it, you see the changes taking place. Then the third one, measure the initial temperature of a dilute sulfuric acid solution. You need to measure the initial temperature of dilute sulfuric acid solution. Add a few pellets of sodium hydroxide to this solution. Stir and measure the temperature again. So you add a few pellets of sodium hydroxide. You stir it well. While stirring, you observe the thermometer reading. So there will be a change in temperature and that is what you need to observe. That is the third part of this activity. And the last one, put a piece of magnesium ribbon to a beaker containing dilute sulfuric acid. So it can be a beaker or it can be a test tube. You take dilute sulfuric acid into a beaker or a test tube and then you put a piece of magnesium strip. And that also it has to be a clean piece of magnesium strip. So that is the last part of the activity. So we'll be doing 4 different changes. We'll be observing 4 different changes in this particular activity. First one, the mothball placed on a hot spoon and you cover it with another spoon and you observe. Second one, magnesium strip being burnt in the Bunsen flame. Third one, reaction between or change when you add sodium hydroxide pellets into dilute sulfuric acid. There you observe the change in temperature. And the last one, we put a strip of magnesium or a piece of magnesium strip into dilute sulfuric acid and there also you observe the change. So I'm sure you all have understood the procedure clearly. Let us go to the lab and do this activity now. Okay, students. So you're familiar with matter. Anything that occupies space and has a mass is matter. We have discussed that before also. And you all know the matter exists in different physical states, the solids, liquids and gases. In addition to that, there can be changes in the state as well as different changes can take place to matter. So in this lesson, we are going to focus on changes occurring to matter, and to understand that we are going to do this activity. So we will look at some examples where changes take place in matter. So to start the activity, I have naphthalene balls or what we call as mothballs in common terms. You can see the mothballs here. Now you know this is a white color pebble-like or pellet-like structures. You have used this at home. Now if we take the mothball, we leave it in a place for about few weeks, you won't see the mothball anymore. What happens there? The mothball goes into a different state. Now here the mothball is in the solid state. It can go into the gaseous state. So here in this activity, what we will be doing is, I will take a spoon, I will heat the spoon and then onto the spoon, I will put the mothballs. So for the heat of the spoon, you can see what happens to the mothball. Thereafter, I have another spoon with which I will cover the first spoon containing the liquid mothball with the second spoon. Then you can see what happens there. Right. So we will need to first heat the spoon. It has to be heated strongly. So I will hold it for some time so that it becomes really hot. In these students, now if we put the mothball and heat the spoon, then of course there is a high chance that while in the flame itself, the mothball will vaporize and it will enter the atmosphere. So we won't have anything remaining in the spoon. That is the reason why we need to heat the spoon first and then put the mothball after removing the spoon from the flame. So I have to make sure that it is heated strongly. So that's why I'm holding it for a longer time. So students, it should be enough heating of the metal spoon so I can take it off, and before I put the mothball, I'll make sure that I turn off the Bunsen burner. There is a chance that the mothball can catch fire. So to prevent that, it's better if you turn off the burner. Okay. So now students, it's a hot spoon. I'm going to put the naphthalene ball onto it, mothball onto it. Observe it. You can see it becoming a liquid. Can you all see that? And you can see the fumes going off from there. So this is what we need to do. I need to close it with another spoon. So here you all can see it becoming liquid. The solid turning into a liquid. We will have to hold it for some time. Now you all can see now the mothball has almost disappeared. Only the liquid naphthalene is there. So I will hold it like this for some time. You will have to hold it for quite some time so that the vapor that is going off from the naphthalene gets condensed on the other spoon, the second spoon, because the second spoon is cooler than the first spoon. So now here students, you all can see the shiny solid substance at the edges of the spoon. So what happened here? When we keep this aside also, you all can see the changes taking place again. At the same time, you all can see the shiny substance, solid substance on the sides of the spoon. So what happened here? Initially, this is the solid naphthalene or the mothball. Then when I put it onto the hot spoon, the solid mothball or the solid naphthalene became liquid naphthalene, and thereafter from the liquid naphthalene there were vapor of naphthalene escaping because of the high temperature. When I closed it with the second spoon, vaporized naphthalene again became solid on the spoon. So it condensed not to a liquid state, but it became it solidified. The naphthalene vapor solidified on the spoon. So there, what is the change? Solid becomes the liquid, liquid becomes the gaseous state, then the gas becomes the solid. So these are all changes taking place where the substance changes from one state to the other, from one physical state to another physical state. Now, if we leave this for some time also, even now you all can see on the surface the solidifying of the naphthalene. So there it is only the solid becoming liquid, liquid becoming gaseous state, and again the gaseous or the liquid state going back to the solid state. So change between physical states of matter. That is the first activity. After this, I will do the second activity where we use magnesium and we heat it in the Bunsen flame. Okay students. So the second activity, we need magnesium strip. Now here you all can see normally we have magnesium strip in the lab. If you look at this, you have learned this before also in one of the previous lessons. There will be a layer formed over the magnesium strip. Although it's a metal, we don't see the shine. The lustrous nature is not visible. But we can clean that using a sandpaper. Now I have cleaned it to a certain extent. Now in these areas you can see the shiny nature, but it has to be cleaned a little bit more. So if you just rub it with the sandpaper, the oxide layer that is over the magnesium strip, that will be removed. So before doing the activity, we need to clean it. Right. Now you can see the shiny magnesium strip. So what I will do is I will hold it with a pair of tongues and hold it to the Bunsen flame so that you can see how the magnesium strip burns in air. We are familiar with this reaction, so we will look at that change now. So now I am going to burn the magnesium strip. I am going to hold it to the Bunsen flame. You all have to observe the change clearly. We will need to hold it for some time. You all have learned the observation, students. When magnesium reacts with oxygen, it burns with a bright white flame. We have learned that before. So here you all can see it burns with a bright white flame. So that is the change taking place there. You all saw the magnesium strip, it was cleaner. So you saw the shiny magnesium strip. Now you all can see the product after I held it to the Bunsen flame. So there you see the white color powder. So there's a complete change. Now even if we let it to cool like this, will you get the magnesium strip back? No, that's not possible. Like in the previous activity, we heated the naphthalene balls, it became liquid. Then I showed you all at the end, after some time, the liquid naphthalene became solid. But here, even if we keep it for a day or two, still we won't get the magnesium strip back. So this is a change where we burned the magnesium strip in the Bunsen flame and it produced another white color product. So with that, I will move on to the next change in this activity. So now the next activity, we will observe the change that takes place when I add a few pellets of sodium hydroxide into sulfuric acid. So here I have the sulfuric acid and these are the sodium hydroxide pellets. So this is a liquid state substance, a solution, and this is a solid state substance. So what we need to do is initially we need to take the temperature reading of the sulfuric acid solution. So that will be the initial temperature. It should not touch the wall or the bottom of the beaker. It has to be completely in the solution, that you all know. Can you all see the temperature, students? Can you all see the temperature reading? It's 25 degrees Celsius. So that is the initial temperature of sulfuric acid solution. Then what I will do is, I will add a few pellets of sodium hydroxide. Now you can see this is the sodium hydroxide pellets. When we put it into the sulfuric acid solution, you all can observe what happens. And also I have to stir it and mix it well so that the sodium hydroxide dissolves. So after dissolving a little bit, I will hold the thermometer in and with that I will dissolve it further. So now students, can you all see the temperature has increased. It is at around 27 degrees Celsius, but still I am dissolving the rest of the sodium hydroxide pellets. So now you can see there's a further increase. It has gone to 29 degrees Celsius. Now the sodium hydroxide is completely dissolved. Can you all see the final temperature, students? So now the temperature is at 29 degrees Celsius. So that is the change that you can observe when sodium hydroxide pellets are added to sulfuric acid solution. Initially, the temperature was 25 degrees Celsius. Once all the sodium hydroxide pellets dissolved, the final temperature was 29 degrees Celsius. So, there you saw a change in temperature or increase in temperature, as well as you saw the sodium hydroxide completely dissolved in sulfuric acid. So, there is a change taking place. So, that is the third type of change. Okay, students. So, the last part of the activity, again we use dilute sulfuric acid and we need a strip of magnesium. So, as I told you before also, when you take the magnesium strip from the lab, usually it is either coated in black color or white color layer. That's the oxide layer. We need to clean it with a sandpaper. So, now I have a strip that I have already cleaned. So, here you can see, if you just clean it this way, you will get it. You can just use the sandpaper and remove the oxide layer. So, you can see the shiny magnesium strip there. So, what we need to do is, we need to put it into dilute sulfuric acid, the beaker containing dilute sulfuric acid. You will see the change. So, I will just break it into two pieces and put it into the beaker containing sulfuric acid. Observe the changes taking place. Now, you can see the solid magnesium and the liquid dilute sulfuric acid solutions. So, there you can see. Can you all see the evolving of gas bubbles? You all can see all around the gas bubbles are being evolved, and also you know that magnesium is usually more denser than water, so it goes down. And they are also from the bottom, you can clearly observe the evolving of the gas bubbles. And you can see the size of magnesium strip will decrease little by little. So, we will have to wait till the reaction is complete. Still, you can observe the evolving of gas. So, there you see a change where gas bubbles are liberated from the mixture or from the medium. You can say that is the dilute sulfuric acid solution and magnesium. When they are together, you will see the liberation of gas bubbles. Still, you can see it occurring. Now, if we take a large volume of sulfuric acid, and I have taken only a small volume here, if you take more sulfuric acid and even if you break it into tinier pieces of the magnesium strip into tinier pieces, when you put it into the solution, the reaction will take place faster and also it will complete faster. But here, of course, you can see the reaction is still taking place. Here you all can see the liberation of gas bubbles. With that, students, now you all can't see that if I touch the beaker like this, I can feel it becoming warmer. So, like in the previous activity, we use the thermometer to observe the increase in temperature. Here also, if you need, you can measure the temperature, but if you just touch the beaker itself, you can feel it becoming warmer. So, there are two changes that can be observed clearly. One is the liberation of gas and the other one is the beaker becoming warmer. So, two changes. Okay, students. So, I showed you all 4 different parts of the activity, and here I have all the final observations that we got from the activities. So, you can remember first we took the naphthalene balls, and that was the solid. When I put it into a hot spoon, into this hot spoon, you saw the naphthalene becoming a liquid. So, there was a physical change from solid to liquid. Then I told you all, I showed you all also, you saw the solidifying process, the liquid becoming solid. But now here you can see it has completely become a solid. So, from the solid we got the liquid, again from the liquid we have got the solid. So, from this observation, you all can clearly understand there was only a physical state change, solid to liquid and liquid to solid again. And also in the previous activity, when I did the activity, you saw the formation of naphthalene solid at the edges of the second spoon as well. So, there also you were able to observe the vapor, naphthalene vapor becoming the solid. So, there is only a physical state change. Then we did the last 3 activities. Second one, I burnt magnesium in air. So there what happened? You all can remember the magnesium strip. It was a shiny silvery metal. So oxygen, of course, we cannot see, but when it burns, we got this product. You all can remember observing this, the white color powder. That is the product. So when magnesium reacts with oxygen, it forms magnesium oxide. So I have kept this for some time, and you all know, even if we leave it for some time or even few days, you still cannot get back the magnesium or the oxygen. So here there has been a complete change. Initially we had a certain type of substance. Now it has formed new type of substances. So magnesium and oxygen were the two initial substances. Now magnesium oxide is the final substance. Then in the third activity, sodium hydroxide pellets, you were able to see the solid pellets. This was the dilute sulfuric acid solution. Into that, when I put the sodium hydroxide pellets, you saw the pellets dissolving completely. Now this is what we got, a clear solution. At the same time, you observe the increase in temperature. So there again, you saw the dissolving of the initial substance in the dilute sulfuric acid solution, and you were able to observe an increase in temperature. Then the last one, I showed you all the reaction of magnesium with again dilute sulfuric acid. You saw the magnesium strip completely dissolved. At the same time, you were able to see the liberation of hydrogen gas, liberation of a gas. So in that also, initially we took dilute sulfuric acid and magnesium. Finally, you only have a clear solution and you saw the liberation of gas. So those were the final components that were produced. So when we compare all four of these changes, the first change is only a physical state change. So there is only a rearrangement of particles, or particles are reorganized so that the physical states changes. So we call that change as a physical change. If you take the last three activities, in these three, initially we had certain substances, finally we have different substances. So there, of course, the change is a chemical change. Initially we had different chemical substances, finally we have different chemical substances. So here students, you all can see, initially we had certain substances, we call them as the reactants, and they undergo changes and form new substances, and those new substances are known as products. And how did we observe those changes? In this, you were able to see the bright white flame. Then you saw the white color powder remaining. And in the second one, you were able to see the dissolving of sodium hydroxide. And also you saw the increase in temperature. Then in the last one, again you saw the dissolving of magnesium strip. You saw the liberation of gases. And also I told you all, when I touched the beaker, you can feel it warm. You were not able to see that, but I felt the beaker becoming warm. So there was a change in temperature. So the substances burning with different colored flames, then the production of new products with or new substances with different characteristics, then dissolving of substances, change in temperature, then liberation of gas, and again change in temperature. All these are observations that help us to identify a chemical change. So from these students, I am sure you all can understand a physical change and chemical changes. Okay students, so did you all observe all the changes clearly? I am sure you all did. So what was the first activity we did? We heated a metal spoon. I heated the metal spoon. I put a few mothballs onto it. And what did you all see? The mothballs immediately become a liquid. So initially you were able to see it around the mothballs, the liquid forming a colorless liquid. And also after some time all the mothballs became just the liquid, the naphthalene liquid. At the same time, when I closed it with the second spoon, what happened? You were able to see the vapor coming out from the first spoon, the naphthalene, when it melted, you saw the vapor being released. At the same time, the vapor condensed on the second spoon. So you were able to observe on the sides and all that the shiny white color substance, that is the naphthalene vapor condensing on the second spoon. So there, what were the changes? The solid naphthalene became liquid naphthalene, and also the liquid naphthalene became the naphthalene vapor. Thereafter, you saw the naphthalene vapor becoming solid. It solidifies and deposits on the spoon. So there you were able to observe all these changes. That was your first observation. So here, first one, naphthalene balls, lean or mothballs. That is our first activity. So you were able to see the solid naphthalene melted and liquid naphthalene was present in the spoon. Then what did we say? Naphthalene vapor solidified on the second spoon. And also, you all were able to see when I let the first spoon for some time, when I kept it aside for some time, you were able to see that the liquid naphthalene solidified again. So that's the third one. Liquid naphthalene solidified in the first spoon. So first one, you were able to see the solid naphthalene melting and forming the liquid as well as evolving vapor. So here we saw the vapor evolved also. Then you were able to see the naphthalene vapor solidifying on the spoon. Then the third one, the liquid naphthalene solidifies on the spoon. That was the first part of the activity. Then the second activity. What was the second activity we did? We burned a strip of magnesium. So here, burning a strip of magnesium. So there, what did we see? Magnesium is a solid, shiny metal. That is, the clean magnesium was shiny. And when we held it to the Bunsen flame, you saw it burning with a bright white flame, and finally a white color powder remains. That was the observation. The shiny metal strip of magnesium burns with a bright white flame. I have written it as burns, but it actually burnt. You were able to see it. The shiny metal strip of magnesium burns with a bright white flame, and we get a white color powder remained. So there, students, the initial magnesium strip, as I told you all, a shiny metal strip that you are familiar with, but the final result after the change took place is a white color powder. So the initial substance and the final substance are completely different. So that is another change, the second type of change. Now the third one. What was the third activity, third step of the activity? Reacting sodium hydroxide pellets with dilute sulfuric acid, or adding sodium hydroxide pellets to dilute sulfuric acid. That was the third one. Adding sodium hydroxide. That is NaOH. Now you are familiar with all these chemical formulae as well. Adding sodium hydroxide pellets to dilute sulfuric acid. That is written as dilute H2SO4. Sulfuric acid is H2SO4. And also we measured the change in temperature. So there, what were the changes you saw? The white color pellets dissolved completely. So white color sodium hydroxide pellets dissolved completely in sulfuric acid, H2SO4. That is the solution. And also, what did we observe? We saw the temperature increase from 25 degrees to 29 degrees Celsius. The temperature of the sulfuric acid solution increased from 25 degrees Celsius to 29 degrees Celsius. So you were able to see the sodium hydroxide dissolving completely in sulfuric acid. After that, you didn't see any solid remaining there, and also you were able to see the increase in temperature. At the same time, even if you feel the beaker, you can feel it becoming warm. So those were the changes that you saw in the third part of the activity. One is dissolving of sodium hydroxide and the change in temperature. Then we did the fourth one. What was the reaction? Putting a piece of magnesium strip into dilute sulfuric acid. So there, the fourth one, magnesium with dilute sulfuric acid. That was the fourth part of the activity. There again, what did you all see? You were able to see the dissolving of magnesium strip, and you were able to see the bubbling, the bubbles, gas bubbles being evolved, or liberation of gas bubbles. That was the observation. So here, strip of magnesium dissolves, then gas bubbles were liberated, and also Here we did not measure the temperature. I told you all students during the activity also, if you want, you can have the thermometer and measure the temperature change. But I told you all I was able to feel the increase in temperature on the beaker. That is, the beaker became warm. So here beaker became warm. So those were the observations of the fourth part of the activity. When we put a strip of magnesium into dilute sulfuric acid, you were able to see the magnesium dissolving and or it undergoing changes, liberation of gas bubbles, and also the beaker becoming warm. So we will look at the observations again quickly. First part of the activity, naphthalene or mothballs. When you put it onto the hot spoon, the solid naphthalene melted and liquid naphthalene was present in the spoon. At the same time, you were able to see the vapor being evolved. Naphthalene vapor solidified on the second spoon and also liquid naphthalene solidified in the first spoon. Then the second part of the activity, burning a strip of magnesium. The shiny metal strip of magnesium burns with a bright white flame and white color powder remains. Then the third one, adding sodium hydroxide pellets to dilute sulfuric acid, that is H2SO4. A white color sodium hydroxide pellets dissolve completely in sulfuric acid. Then the temperature of the sulfuric acid solution increased from 25 degrees to 29 degrees. Here, of course, we are not doing any calculation, so the values are not very important, but you all understood that there is an increase in temperature. That's the important thing. Then the last one, we were able to see that magnesium, when put into dilute sulfuric acid, the strip of magnesium dissolved, gas bubbles were liberated, and the beaker became warm. So from all these four observations, students, the first one, from solid, we got the liquid and the vapor, the gaseous state, but the gaseous state vapor became the solid again, solidifying process, and also you were able to see the liquid becoming the solid. So there you saw the change between different physical states of matter. We had the solid to liquid, liquid to vapor, or solid to vapor, and vapor back again to solid, as well as liquid back again to solid. So there only the change in state of naphthalene took place. Only the physical state changed. So therefore, we call it the physical change or the state change. So there matter underwent changes, and that change only in the physical state of matter. So therefore, we call it a physical change. But in the other three, when we burn magnesium, initially magnesium is a shiny metal. Finally, we get a white color powder. Sodium hydroxide pellets were there. When put into sulfuric acid, they completely dissolve. Even on cooling, even if you leave it aside for even a day, you won't get the sodium hydroxide back. And you were able to see the increase in temperature. In the third step, you were able to see the magnesium strip dissolving and completely dissolving off. So again, we cannot get the magnesium strip back, even on cooling. At the same time, you were able to see the evolving or liberation of gas bubbles and the beaker becoming warm. So in all these three changes, initially we had certain type of matter and finally we got different types of matter. So there was a change from one type of matter to different types of matter. One in the sense the initial type of matter became a different type of matter. Such changes are known as chemical changes. So initially you have matter which are usually called as reactants. We will be discussing that again also. So initially you had magnesium, that is the reactant. Finally you had the white color powder that was produced during the chemical change. So these types of changes are known as chemical changes or chemical reactions. So from these 4 observations, students, the first one only involves the rearrangement of particles within different states of matter. The three states of matter, that is solid, liquid and gases. You all know in solids the particles are very tightly arranged, whereas in liquids there is a certain distance between the particles and there is a certain amount of movement. Whereas in gases, the particles are completely randomly arranged. So there, when there is a physical change taking place, there is a state change taking place and the arrangement of particles within matter changes. But in a chemical change, initially we have certain types of chemical substances, finally we get different types of chemical substances. There, of course, the initial type of chemical substances undergo chemical changes and different types of chemical substances are formed. So, they are known as either chemical changes or chemical reactions. So, we will be concentrating more on chemical reactions in this lesson. I am sure you all can understand that. So, with that understanding, we can write down the conclusion. So, the conclusion. So, in the first activity or first part of the activity, the change takes place between physical states. So, they are solid, liquid, gas, and again back as well. So, these types of changes are known as physical changes. So, here also you were able to observe the change from solid to vapor. Again, vapor condensing to form solid as well. So, either way, it was the change between physical states. So, these types of changes, this type of change is known as physical change. In this, only the rearrangement of particles occurs. So, that is the first type of change. In steps 2, 3 and 4, the initial substances underwent changes and new substances were formed. So, there we had initial substances and they underwent changes and new substances were formed. What do we call that? As chemical changes. So, here these types of changes are known as chemical changes or chemical reactions. You can call it the chemical change or the chemical reaction. So the first one is a physical change. The other three are chemical changes. In the first physical change, only the states change from solid to liquid, liquid to gas, or solid to gas, and gaseous state back to solid state. So when the state change takes place, there is only a rearrangement of particles taking place. But in the other three, the initial substances are converted to new substances. So that type of change is known as chemical change or chemical reaction. In these three chemical reactions, students, now in the first one, you burn magnesium in the Bunsen flame. What was the change you observed? You saw the bright white flame. Then we got the white color powder as the final substance. In the second one, you saw the dissolving of sodium hydroxide and you were able to observe the increase in temperature. So you saw the bright white flame, then you saw the increase in temperature. Then also when magnesium reacted with dilute sulfuric acid, you were able to see the liberation of gases. Similar to that, we can also see the formation of a precipitate. Sometimes when you mix two substances, for example, we will be doing this later as an activity. When you mix barium chloride with sodium sulfate, you will see the formation of a white color solid substance and it will deposit at the bottom of either the beaker or the test tube. There we call that as a precipitate. So a formation of precipitate. So liberation of a gas, change in temperature, it can be either increase in temperature or decrease in temperature. Then we can see the dissolving of substances and also we can see the formation of precipitates. In addition to that, there can be color change as well. For example, again, if you take a solution of copper sulfate, if you put a few pieces of zinc into it, when zinc metal dissolves, you will see the color of copper sulfate decrease. So there can be color change. All these are different observations that help us to identify chemical changes or chemical reactions. So in the next slide, I will be discussing such type of changes. So evidences for the occurrence of a chemical reaction. The first one. So here, first one, we can say liberation of gases, or another term that can be used, effervescence. Effervescence means the evolving of gas bubbles from a solution. So that is when magnesium reacts with dilute sulfuric acid. So here as an example, we can consider the chemical reaction where magnesium and dilute sulfuric acid. Then we have another observation like I told you all, burning with bright white flame or burning with colored flame. Flames. So here as examples we can say magnesium burns with bright white flame. And you are familiar with another example. Sulfur. We have discussed this before in another lesson. Sulfur burns with blue color flame. So another example, sulfur burns with blue color flame. So again, chemical changes. Then another one. Change in temperature. Change in temperature. Temperature. So there we can say increase in temperature. Increase in temperature. What are the examples? We looked at one, sodium hydroxide and dilute sulfuric acid. So I will write the chemical formula. You are familiar with that. Sodium hydroxide pellets with dilute sulfuric acid, H2SO4. What else? Magnesium with dilute sulfuric acid. Magnesium with dilute sulfuric acid, H2SO4. Two examples where temperature increases. Then temperature decreases. Another one, decrease in temperature. This again you might have experienced in your day-to-day life, children. For example, when you take a little amount of glucose, when you consume a little amount of glucose, as you put the solid glucose, the glucose powder into your mouth, you can feel the temperature decreasing, the mouth becoming cooler. You can feel that coolness inside. So there is a decrease in temperature. So when we dissolve glucose in water, or when we dissolve ammonium sulfate in water, there is a cooling effect. That is, the temperature decreases. So as examples, we can say glucose dissolved in water, or ammonium sulfate dissolved in water. Then after that, I have written the evolving of gas bubbles, then burning with colored flame, change in temperature. We discussed two more changes. What are they? Formation of precipitate. Formation of precipitate. Formation of precipitate, I told you all we will be doing that activity. Most probably in the next chapter I will be discussing that. When we mix sodium sulfate with barium chloride, there we will get the precipitate. A white color solid substance will deposit at the bottom. Sometimes you will see a red-brown color or brown color solid substance depositing. So those are all formation of precipitates. The precipitate, again depending on the compound, students, the color can vary. Another change. What is the other change? The change in color of solution. So here, change in color of solution. So as an example, I told you all a reaction. You have observed this in your previous grades also. When we do electrolysis of copper sulfate, the decrease in blue color of copper sulfate solution. A similar thing can be observed when we use copper sulfate solution and zinc metal. Blue color of copper sulfate decreases. So that is another observation that can be used to identify chemical changes. If I go back and look at all the changes, evidences for the occurrence of chemical reaction or chemical change. Liberation of gases or effervescence. Example, magnesium and dilute sulfuric acid. Usually, you have learned this before also. Metals, when they react with dilute acids, they evolve hydrogen gas. So, liberation of hydrogen gas. That is a common reaction. You can give as an example. Then the second one, burning with colored flames. That again, magnesium burns with bright white flame. Sulfur burns with blue colored flame. Then change in temperature. When we say change in temperature, it can be increase in temperature or decrease in temperature. Increase in temperature, sodium hydroxide with dilute sulfuric acid or magnesium with dilute sulfuric acid. During these chemical reactions, there will be evolving of heat. That's why the temperature of the beaker and the solution increases. You can feel it with your hands as well as you can measure it using the thermometer. At the same time, there can be decrease in temperature also. So, when glucose dissolves in water, ammonium sulfate, even ammonium nitrate, when it dissolves in water, there is decrease in temperature. And then we discuss the formation of precipitate. Precipitate, again, a solid substance separating from the solution and depositing. So, for example, sodium sulfate reacted with barium chloride will give rise to a precipitate. Then the last one is change in color of solution. For example, copper sulfate solution and zinc metal. Then you will see the blue color of copper sulfate decreasing. At the same time, you will see the brown color solid depositing as well. So that is something that happens. From these observations, students, you all have to understand in one particular chemical reaction, there can be more than one changes. For example, magnesium with dilute sulfuric acid. You were able to see the effervescence, that is liberation of gases. At the same time, the beaker becomes warm. So, increase in temperature. The same way, when we dissolve or when we put sodium hydroxide pellets into dilute sulfuric acid, you can feel the beaker becoming warm. We measure the temperature also. At the same time, the solid sodium hydroxide dissolves completely. So, again, two changes that are observed, visible. Magnesium being burnt, you see the bright white flame and the formation of white color powder. So, in a chemical change, students, you all have to understand there can be either one change that is very visible or there can be more than one changes that are evidences that the chemical reaction is taking place. So, I am sure you all can understand that clearly. So, with that, students, I am going to end this chapter, and in the next chapter, we will continue discussing about chemical reactions.